We have air. What's up, YouTube? It's Mike from the old Viking Motorworks. Out working on the C3 LS swap. And it's getting hot here in Florida. I had this set up to run AC, and I've been working on that little by little. Drivability is great now, runs good. I'm trying to dot the I's and cross the T's on this thing. And part of that was getting the AC working. So I'm going to cut, well, I should say I already cut a bunch of the stuff out. I just don't think it's that interesting to have a sped up, garage view of me running back and forth with fittings and putting stuff together. And it's like, I don't know, man. Maybe it is, maybe it's not. Sometimes I just get in the zone and I want to get stuff done, and I just don't think about picking up the camera, and that's on me. But anyway, so we've got a Sandin 508 compressor mounted here. This originally came with a rear head back here that had the ports sticking straight up, and they hit the bottom of the hood, so I had to get a new rear head plate. That was easy enough to change. It's just 5 bolts on the backside, and that set the ports straight out the rear. The lines were a little tricky to make up, but finally I cut to the chase. I had got one of those universal AC line kits that comes in an assortment of fittings and hoses, and it seemed like a great idea. 100, 120 bucks, 150 bucks for one of those kits, and it just didn't work out. None of the fittings were the right size. I would have had to just throw away 3/4 of the fittings they sent me, if not all of them. So what I did was, since this is like a hybrid between an LS with LS AC controls and a Sandin compressor, which didn't come on the LS, and the original 1982 evap and condenser, what I did was I got an original replacement high side liquid line, which runs from the condenser down there. You see it looping. I had to put a bit of a loop in it to get it to clear around. It did not quite come bent exactly the right way, but it works and it holds. There's no leaks, and it works fine. So that liquid line that comes up from the bottom of the condenser. All right, I'm back. So the way these AC systems work, and this is most AC systems, there's some variations between orifice tube systems and TXV systems and recirculation systems, but largely they work the same way across the board, whether it's automotive or residential or commercial air conditioning systems. If it's a true refrigeration system, basically you compress Freon. We use Freon because Freon has a direct relationship between temperature and pressure. As as you increase pressure, it condenses into a liquid and it releases heat. And as Freon evaporates, when you relieve the pressure, it absorbs heat. So these work. They almost all work the same way in one sense or another. They have a compressor, and this takes the gas Freon and compresses it into real high pressure. That raises the temperature, brings it up to 200, 220, 250 degrees, and it compresses it into a high pressure, high temperature gas. That comes out that number 8 hose you see down there off the high end fitting, the high pressure fitting, and runs up and goes to the top of the condenser. And when it gets to the top of the condenser, it's still a high pressure gas at high temperature, and it hits the airflow coming across that condenser, cools it. As it cools, it condenses. So it condenses into a liquid. It's still at high pressure because the whole condenser is pressurized, but it now is a liquid coming out of the liquid line on the bottom. So what I ended up doing was using a factory 82 Corvette liquid line that runs up, and I had to put a couple of custom bends in it to clear some stuff. And it wasn't bent quite right. I needed to get it to fit. I didn't want the pipes rattling off the core support or the radiator, so I had to space them out. I ran that liquid line, comes up. So this is now a high pressure liquid. Comes up the high side line and goes through the orifice tube. And the orifice tube is just what it sounds like. There's a little tube inside this line, right below this rust-colored fitting. And the orifice lets a little bit of Freon bleed through at a time. And what that does is, since the other side of that orifice is under suction from the compressor, it creates a low pressure area, and the Freon evaporates. When it evaporates, it absorbs heat like crazy. So as it goes into the evaporator, it goes in as a gas, and in the evaporator, it absorbs all the heat of the air passing across the evaporator, and that's why you get cool air out into the cabin, because it absorbs the heat in that air. It doesn't put cold into it. You can't put cold into anything. The only thing active thermally is heat. You either add heat or remove heat. So it removes the heat, and some of it, a lot of it, and it goes out the top line of this evaporator, which you can see right there, and goes down into the accumulator. And that basically, there's some oil in there, there's a filter in there, it absorbs any moisture, there's a bunch of stuff in there. and it comes out of the accumulator through this number 10 line and back into the compressor again, and the process repeats. So, you know, I had the compressor wired up the same way 82 was. The same controls from the HVAC, which is just an old school dumb panel on the dashboard or on the console that turns the compressor on and off. And then the compressor runs and, you know, till you turn the switch off. Well, that was fine when I had a mechanical fan, which constantly drew air through the condenser. The problem is with electric fans, that condenser overheats really fast. I mean, it'll blow up, 300, 350 PSI on the high side, and you're not doing any cooling. You're loading the compressor down. You hit a certain pressure, whatever the pressure, if it's got a pressure relief on the back head, which this one doesn't, these lines have a limit. If you push 450, 500 PSI, you're going to start blowing fittings off and splitting lines, and you can't just run max pressure. On top of that, you're still not getting much flow through the orifice. You're not really doing any cooling in the cabin. Anyway, that the pressure will keep skyrocketing until you blow a line or the compressor fails or something like that. One of the compressor seals or. So what I needed was to be able to turn the cooling fan on and off. And this is a two-stage fan. It's got a low speed and a high speed. I needed to at least turn the fan on low speed to pull air through the condenser to get some air moving to bring the high side pressures down to a reasonable level so it wouldn't max out. I mean, within 10 or 15 seconds, it was climbing well over 200 PSI, and it was up. It would just continue to climb. Within 30 seconds, it was a 300 PSI, and that starts getting scary. You get over 300, then you start worrying about, blowing seals out and whatnot. So I could have just jumped one of the fan relays into the compressor, so anytime the compressor's on, the fan's running, which is fine, I guess. I mean, it would get it done in the short term, but that's really kind of a ghetto way to do it when I have an LS engine with an LS PCM and all the controls built into it, because not only will the LS turn the fan on and off appropriately, but it'll also bump the idle, it'll change the load parameters, it'll control the compressor turn on and off as well. So what I did was disconnect the wire from the compressor that I had run and fed it into the ECM. And so what I've done now is basically created a hybrid. And what I had to do, and I'll break this out for you, when you go into HP tuners, and set this up. Let me get my spectacles on. I don't have my glasses. Son of a bitch. This is my day, walking back and forth, looking for the same shit I just had in my hand. Like my glasses. And my cigarette going out. All right, so in HP tuners, if you go into System, under AC, now this originally, let me pull up the compare file from the original truck, and this is ECM's out of a 2003 Silverado. So you can see these are grayed out because this was controlled. The AC was controlled by a body module. It was set up as serial cycling, which meant it was serial controls from the AC control head, and that would really control the AC system cycling. Cycling is what happens. Basically, it keeps the low side from drawing down too low, and it keeps the high side from going up too high. If you draw it down too low, it sounds like yay, more cool air. But the problem is you drop it so low that all the water that's condensing on the evaporator when it's running will freeze up, and you'll end up with a blocked evaporator and then no more cool air. So you basically want to go down to like 25, 30 degrees, and the warm air passing across it should cool it. Should be keep the evaporated water draining out the bottom and not just freezing up. So there's a lot of talk on the internet about how to set up the air conditioning on these conversions. And one of the schools of thought was, if you had a serial cycling, you can't change to anything other than one of the other cycling methods. So you'll see the options here are serial cycling, analog cycling, passive, nobody knows what that is, and AC, and not fitted, I guess, means it has no AC. So this was originally serial cycling. So I had gone to analog cycling. And the difference between analog and serial is fed the command to run air conditioning through a serial communication. Analog is the 12-volt input. So I'm using analog. and I had set to analog cycling, and it would run the AC okay, but it wouldn't turn the fans on and off. So I switched it to analog against conventional wisdom, and it works just fine. So now it's controlling the fans and everything. As a matter of fact, if I go into my log here, you can see in the middle, I've got AC requested, which is the 12 volt in from the HVAC head on the console, which is fine. That's the analog input. If I had it set to serial, it wouldn't even recognize it because it wouldn't be looking at that pin on the ECM to tell it the air conditioning's on. Then it's sending the signal. It's sending the signal back out to run the air conditioning. So it's sending the compressor engage signal back out, which then runs through a relay and engages the compressor. And then it's looking at a high side pressure sensor, which tells it how much pressure is on the high side. That's what it uses to determine whether to turn the fans on or off. If you go into the AC settings again in Editor, you've got AC enable pressures. So at 180 psi on the high side, or 220 psi on the high side, it'll turn the low speed fan on. And then eventually, if you're driving down the road and it's cool out and you drop the AC pressure down below 180, it'll shut the fan back off, which is fine. So I want this fan. It runs right in the sweet spot right here. If it's super hot day and you're running real high pressures and it gets up to 255, it'll turn on the high speed fan and really suck some air through the evaporator. So if I'm sitting in traffic on the highway and it's 95 degrees and 90% humidity, it's going to run the high speed fan and cool it down. And the same thing, as it drops down to 230, it'll come off a high speed and go on to the low speed fan and then continue to drop as the needs drop. So this is a real benefit to be able to run both fans with the AC and be able to have it control the idle as well. If you look in, let me get out of system, I think it's in torque. Yeah, in torque management, we've got the AC air conditioning torque. So these are all the settings to control the engine idle and bump those factors up and bump the other controls up based on this. Also will reduce timing as well. So when the compressor initially engages, that load hits really hard when the compressor locks up and starts spinning. It'll back timing off a couple of degrees, and you can set up what the max retard is depending on where it is. If it's idling here, it'll do the max retard coming off. It'll never be up there, so I'm not worried about that. How much delay there is until it takes timing out or adds timing until it takes timing out, and then how much delay until it adds the timing back in once the compressor starts spinning. So that all seems to be working fine. I got a little bit of an idle bump when it first engages, but I can live with that. I may monkey around with the inertia torque a little bit and see if I can get it to see if I can drop those a little bit and get it to not bump the idle quite so much, because it's going to look at the inertia torque and it's going to apply that to the torque model and then adjust the airflow through the IAC to keep the idle at the correct level. This particular ECM and OS doesn't have, there's a base running airflow, so these are the idle parameters. It does not have different airflow settings for AC on or off. It's either gear or park neutral. What I can do is go into the base idle settings, and I can bump the idle up a little bit with AC on. As you can see, I've got in gear AC on or off, or park neutral AC on or off. They're set the same right now. Honestly, the idle level is fine with the AC on. It's just the initial flare when it engages. So I think that's more the torque model and the torque management regarding the AC compressor coming on. It doesn't come on as hard as it thinks it's going to. So I'm going to drop that inertia torque a little bit, and we'll see how that feels or how it acts. So what I had to do was repin the ECM. And I used a universal LS swap harness off of eBay, and I verified all the pins before I did the install, and it was wired okay. And it's a clone to a PSI system. And what I had to do, I want my artwork. All right, so what I had to do was rewire this thing. And the way I had this originally set up, and the way the car was originally equipped in the factory, is a HVAC head would send out a 12-volt signal through the low pressure switch, and then we'll go out to the compressor from here, and it would drive the compressor directly. And basically, this is a low pressure cycling switch. So if the low side pressure drops below 21 or 22 psi or 20 psi, it'll open and allow the compressor to come back, the pressure to come back up, and then it'll close and cycle the compressor again. And the purpose of this is that if the freon leaks out of the system, the freon and the circulation of the freon carry the oil with it that keeps the compressor lubricated. So if you run an AC compressor with no freon in there, you'll fry the compressor, you'll cook it, you'll burn the bearings out of it and the seals and all that stuff. So this really protects the compressor. It also protects the evaporator from freezing. So if the pressure drops way too much, it'll open and let the compressor turn off, let the low side pressure climb back up again, and the evaporator pressure, and it'll warm up and it'll burn off. It'll melt off some of the frost on it if it's gotten that low. So this is why when you turn on, if you ever turn on the AC in your car and it's cycling back and forth, ka-ching, 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 you're low on Freon. It's tripping this switch. The Freon's typically much higher, that it wouldn't trip the switch unless you've lost some Freon. You don't have the right system pressure. So I disconnected the line coming off the low side switch, and I use that to go do a couple of things. It sends power to the activate side of the relay, the controlling pins of the relay that are going to drive the compressor, because this is, there's enough power coming through the HVAC head and the low side switch to drive the compressor. That's the way it was originally configured. But if I'm going to use the ECM to control the compressor, it can't supply enough amperage to run the compressor clutch that would cook it out. So what they do, the LS ECMs output a negative signal to engage the compressor. So I wired a relay in. It's pretty simple. The typical 4-pin relay. There's also going to be an 87A terminal in the middle here that's unused on most of them. If you have a 4-pin relay, it's just going to be the 85, 86. 30 is the power in, and 87 is the load out. If you have a 5-pin, it's going to have 87A in the center, which is really just, all that means is that it's connected to 30 when the relay is not active. When the relay is active, 30 gets connected to 87. So I have 12 volts coming out here. Some goes up to feed the supply power for the clutch, which isn't driving the clutch yet. It's just sitting there waiting. It's the same as having a 12-volt run direct to the battery, but it was convenient. It was right next to it, and I know it can carry the current. So it runs to the positive side of the relay coil that engages to close the relay switch, and then it also sends a signal to the ECM to tell the ECM, hey, we want to run AC. Now the ECM decides, okay, we should run AC, and all the other parameters are met, like staple idle and some other stuff. It'll send out a signal to engage the compressor. As a negative signal comes out and hits the other side of the relay coil, and that basically activates the relay, connects 30 to 87, and sends power to light the AC clutch or close the AC clutch on. So that's that. The ECM, I had to wire in 5 additional contacts that weren't on this harness. Now, of course, it was the same LS style ECM connector, C1 and C2, so that was fine, but they weren't pinned into the wires. Luckily, I held on to the old harness from the LS that came with this LS and made myself some little pigtails with the terminals already attached. I guess about foot-long pigtails, and that came in incredibly handy because basically I even found the right color codes to match those pins, which was 2 grays, a red, black, a white, and then a black. 80s to the ground. It's the ground for the sensor ground, so I knew that was black. Now on connector C1 to the ECM, it was just a single pin, gray at pin 45, and on C2 I had 4 to add. So red, black at 14, white at 17, gray at 43, and then black at 80. And the reason I had to run so many extra pins, not just the compressor controls, is that part of the system to run the fans works off the pressure on the high side of the system. So what I did was I had to install a high side sensor, which is not just an on-off switch. It's not a trinary. It's a transducer that relays the exact variable pressure from the high side to the ECM. So the ECM tracks that pressure climbing up and down as the compressor cycles and as airflow changes. And conveniently, I had to make up my own O-ring to seal it, but that high side switch mounts right into the original R12 port on the high side liquid line. So that was fantastic. So I was just able to find the right side O-ring, and it's screwed right on. And I took the connector off my old LS harness that came with the motor and wired it in. I had everything all loomed, zip tied, and tucked up pretty. There's the relay for the compressor. And so what's going on now, I've got full function of the fans, just like on any of the LS motors that came on electric fan equipped vehicles, like some of the GTO and Camaros and Corvettes, I think, didn't run mechanical fans. But the problem is those are all later years through like Gen 4. So this is like a hybrid. And as it's running, and I'm going to set this to run and play, and you can see what's happening. So there's the actual signal coming from the high side switch on the high side, telling the ECM exactly what the pressure is. And you can see it right now, fan 1 is running. Now it doesn't give me, I'm going to zoom out a sec, hang on a sec. Let's get back to before it came on. Let me see requested. All right, so you see here, I've just started it. AC is requested, so I've got a 12-volt signal coming from the HVAC head through the low side switch up to the ECM. The ECM is not active. The ECM has not turned the compressor on yet. It's waiting for it to the idle to stabilize because it just started. So I hit run. Now it's running, and you'll see it engage the compressor. And you see the voltage on the pressure sensor is pretty stable. Now it engages it. Now look at the voltage climbing. So as it's building pressure on the high side, it gets to the threshold and turns on the number 1 fan. That's exactly what I want. It's perfect. That's exactly what I wanted it to do. So now I've got full function instead of, doing, like I said, I could have got away with just running the fan, tapping into the low speed fan relay and connected it to the compressor lead and keeping it simple, but I would have lost all the other functions that the LS computer is capable of handling. And, there's other stuff in there as well. There's, you can set the throttle position where you want to disable air conditioning. So if you're, if you're getting on it and you want the AC to come off, or you don't want to overspool the compressor, you can set the RPM limits on it. Right now, if that AC switch is on, or the way it was before, if the AC switch was on, and you got into the throttle, and I'm spinning, 5,800, 6,000 RPM, that compressor's spinning the whole time, and that's not terribly healthy. And so, you can go in and set. Oh, wow, it was just there. So it'll disable at 5,200 RPM. It'll disable at 90% throttle. So if I'm just bucking around town, it's going to stay on. But if I hammer it, then it'll turn the AC off. So I get, max torque, and I don't have to beat the compressor up. And then once I drop below 50% throttle, it'll re-enable the air conditioning compressor again. And, so there's a lot of variable things that come with the LS computer and the LS operating system, that really help maximize your benefit of having AC and not sacrificing anything else. So to me, it was worth it. It's 5 pins, and I ran a new loom to feed the wiring across, and got everything stocked up. And the end of it doesn't blow like nice. It's 82 degrees here in the garage, 84 degrees, and I'm blowing like 55-degree air through the vents. So I'm pretty damn happy with that. And that's just running for 5 or 10 minutes. Once everything cooled down, once the cabin cooled down and everything else, driving around with the AC on, it'll blow colder than that. But that puts me at about 210 pressure on the 210 psi on the high side with the fan running, which is fine. That's about where I want to be at idle with the R134 system. R12 used to run a little bit of lower pressure. 134 runs a little bit higher. And then, of course, I think the newer, I don't know what the newer one is, like 430YC, some stupid shit they changed to a couple of years ago. I think they run even higher pressure. But that's it for now. AC is running, blowing cold. I'm a happy dude. I'm going to be a little less sweaty driving this thing around. And I had the hood off, as you notice, or I have the hood off, because when I did the hood cutout, this had a double layer. You can see some of the residual scarring from it. There was a second layer of fiberglass that was laid down over the hood on the underside that had a cutout to feed the crossfire injection intake. And when I cut this out to fit the intake through, really I just rough cut both layers the same size. And I finished the top side so it looked nice from the top, but the underside still looked all ghetto. The fiberglass was, fiberglass fibers, and it looked all shitty. And so basically I got a chance to get a heat gun and melt off that inner layer of fiberglass, soften the glue up, and I just scuffed it down and shot it, just rattle canned it to clean it up so it doesn't look so ghetto. And I got to hang the hood back on it now that I'm all done with the AC, I think. One more thing I did is I had it out for its longest run. I went out for about an hour one-way drive. Came back at nighttime, and I faced the reality that 43-year-old headlight system is inadequate by today's standard. They were half pointed at the ground, and 2 of them are yellow, 2 of them are white, and it was pretty ratty. So I took the opportunity to come in and redo the headlights, and I replaced these bezels. The black surrounds are like 87, 85 bucks, or ABS plastic. They're fine. They painted up nice, and they had LED style headlights. Now, instead of just the outer 2 lighting on low beam, all 4 light up on low beam, and all 4 also light on high beam. And they came with those little those little LED bands that run across the center, which I didn't really care about, but I had them light up on low beam. You can wire those separately if you want, but I didn't really want them lit while the parking lights were on or anything, because you're going to be looking at, you'd be pointed at the ground anyway. And so that's it for today. I'm resisting the urge to start on the bodywork. I got the hood off and I started poking around. I got to clean this crack up and reseal that and lay in some fiberglass, and there's a bunch of stuff. There's another crack on this fender. Look at that go, huh? And so it needs some body work, but you know, this tiny little, well, you know what I usually say, 10 pounds of shit in a 5-pound bag in this garage, and it's just not, it's not conducive. I mean, I've seen guys do body work in smaller garages, and I'm not going to whine like a baby about it, but you know what? I just don't feel like it. It's too damn hot. It's too cramped in here, and I'm in no mood to pull everything, everything out of here, because I'm not going to go I'm not going to go blowing off all the fiberglass or the razor blade and sanding and everything else and just covering everything else in my shop with paint flakes and dust and all kinds of crap. And I got my washer dryer in here and a bunch of other stuff, and you know, it'll be a disaster. So I think I'm going to resist the urge this year. Wait till I get settled. I'm still looking at moving next spring, and get set up. I'm going to have a much bigger shop. I'm going to set it up with a nice like 30 by 40 garage. That's really just going to be work. I'm not going to have my washer dryer here, which kills me. And I'll have some space and lighting and everything else. So I think I'm going to hold off on the body work this year and just go beat it up the way it looks, because 20 feet away it still looks pretty good. And that's it for today. Thanks for tuning in. I'll talk to you guys later. Hey, by the way, don't forget, subscribe. I look at how many views I get on my videos, and it's a lot of views, but there's like no subscribers in there. Most of the people that watch don't subscribe. Do it. Hit the subscribe button. It'll keep you up to date on anything new I post on what's going on with the vet and the bikes and all kinds of whatever other toys I decide to get in here in my new shop. All right. Thanks for watching. Talk to you. Bye.